Hello, welcome back. The title of this lesson is called Frequency Tables, Part 1. So I am excited to teach this because I remember when I first learned the idea of a frequency table, it was very confusing to me, kind of overwhelming a little bit. So what we're going to do is present a scenario, I'm going to give you some data, and then we're going to construct a frequency table together so you understand exactly how it's built and you're not guessing in terms of what to do. And then I have a pretty version, a nicely formatted version of the same information, and you'll know exactly how it was done because we're going to do it together. Once we have the frequency table in place, we'll be able to answer some questions about the data. Now, a frequency table is a very common way to present what we call statistical data. When you have lots and lots and lots of numbers, you know, if I give you 500 numbers and just put them in a line, I mean, nobody's going to be able to do anything with that. A frequency table is a really good way to sort of represent all of the data in one place in an easy to digest format, all right? So for our first problem, we say Kelly collected data on the temperature at which people in her community set their thermostats. So basically, houses in the neighborhood, she goes down the, down the street and says, what temperature do you like to set your thermostat at? One person says 68 degrees. She goes next door, that person says 69 degrees, and so on. I have all the numbers here. Now, I've already put them in order. In reality, it'll be very random. One person will say 80 degrees, next person will say 73 degrees. These are all in Fahrenheit, but you know, it doesn't matter. The temperature scale we're in could be Celsius, could be Kelvin, which is another temperature scale we'll learn about later in chemistry and in physics. These are in Fahrenheit, okay? So we have all of the data here, and I've already put it in order of least to greatest. So every number you see here is a different house. So you can see lots of people chose to put their temperature at 70 degrees. Lots of people chose 71. Lots of people chose 72 and so on. But still, look at all those numbers. If you look at all the numbers and just try to understand what everyone in the neighborhood is doing just by looking at numbers, it's basically impossible because you have all these numbers and we're not human computers. And so I can't really tell you how many percent of people prefer to have their temperature above 73 degrees. For instance, I can't easily see that. So what we're going to do is construct a table to summarize this information, and it's called a frequency table. The word frequency. Frequency means how frequent something is happening. There's a science definition. We'll talk about frequency of waves. We'll talk about that later. Higher frequency is a faster wiggling wave, right? The faster goes up and down. But in this context, when we say the frequency that something happens, it means a higher frequency means it happens more often. So the numbers that are in here more often are going to have a higher frequency because they're more frequent. Frequent kind of means frequency. Higher frequency means higher, the higher frequent that situation is happening. Now we want to boil this down into a table. I am going to show you a peek at what we're trying to do. This is the completed frequency table. This is why I didn't want to start out just by talking about this table because it's kind of overwhelming. You have a bunch of numbers over here, the temperature, we have this thing called frequency, what does that mean? Then we have something called cumulative frequency, what does that mean? And then we have something called relative frequency. So we have frequency, cumulative frequency, relative frequency. As with everything in life, once you understand the definitions, then everything's easy. So this is where we're going. Don't stress out about it. We're going to create this table right now ourselves, and then we're going to have a pretty version of it here, but our goal is to fill this table out. So let's go over here and let's start by talking about what this data represents. It is the temperature people want to put their thermostat at, right? So what we're going to do is we're going to make a column. And the first column is going to be the temperature. This is the temperature that people respond to us and tell them that they want to set their house at. Now we've already ordered the data from least to greatest. So you can see the temperatures range from 68 all the way to 73 degrees. We don't have anybody lower than 68 and we don't have anybody higher than 73. So all of the numbers that go in the temperature column are all of the temperatures that we got for answers. So some people wanted 68 degrees, right? Some people wanted 69 degrees, right? Some people wanted 70 degrees right here. Some people wanted 71 degrees. Some people wanted 72 degrees. And finally, some people wanted 73 degrees. So in the temperature column, we're just listing all of the unique responses. So in this case, it's all about temperature, and we got numbers back. But the data could be, what's your favorite color, right? And so I ask 100 people what the favorite color. Some people would name red. Some people would say blue, some people would say green, some people would say pink, some people would say purple, some people would say brown, some people would say black. And those answers would be the ones that we would list in the table because those are all the answers we got. Now what we have to do is we have to try to see how often people responded with this, with these numbers. So we have something called the frequency. Right? So we have something called the frequency. Remember, the frequency is how often something is happening. So we look at the data here in the table here. 68 degrees only occurs one time. Only one person answered that. Very low frequency. Low means it doesn't happen very often. Only one person. So under the frequency column, you're going to put down how many times that occurred. How many times that answer happened. And it only happened one time. Now for 69, that happened 1, 2, 3, 4 times. So we had 4 different houses answer 69. And then for 70, 1, 2, 3, 4, 5, 6, 7 people answered 70. And then 71, we had 1, 2, 3, 4, 5. 5 people answered 71. And then 72, we had 1, 2, 3, 4, 5 answer 71. And don't worry about this table being so pretty because we're going to make a pretty version in a second. And then we had 73. Only 3 people answered 73. So before, whoops, I put the wrong number here, not 7, it should be a 3. Only 3 people answered 73 degrees. Now before you do anything else, this table by itself has a lot of value. We have 1, 4, 7, 5, 5, 3. Because it's very hard to look at this data and for you to tell me what was the most common temperature. I mean, you could count them, but you see, what if I gave you 500 numbers? You're not going to be able to look at all those numbers and tell what the most common one is. But if I present it in a table, all of the data is here, and you can immediately see, okay, the most common answer was 70 degrees. We had some people a little bit higher and some people a little bit lower. And look, the farther we got away from the most common answer to 68 and to 73 degrees, then fewer people had that setting. So that's very common in real life. You'll have like a most common answer where most of the people will answer. And then as you go farther away from that, the frequency goes down. So remember, high frequency means high number of respondents because it's more frequently answered. And as you go farther away to more extreme cold, more extreme hot, then fewer and fewer people want to set their thermostat there. So the answer is less frequency. So we have high frequency here, a big number, and low frequency here for a small number. Now again, this table is very valuable because you can see right away, okay, this is most common. Okay, this is not so common. And it's way easier to digest this than to look at this table. All right, so the next thing we have to talk about is the cumulative frequency. Cumulative frequency. So I'm going to call it cumulative freq. All right, now I'm going to tell you right now that this table, this column, it's useful, but it's not maybe the most important table in the column, in the chart, okay? What we really want to know is how many people responded. You know, if I ask you, because it's useful to know, we had 1 person answer this, 4 people answered this, 7 people answered this. It would be useful to know how many total respondents we have. So we're going to add them all together. And we can add them all together. And we can see in this case that we're going to get 25 because this is 10, right? And then this is 10 more, that's 20. And then that would be 25. So there's 25 respondents altogether. But the cumulative frequency just makes it a line entry where we start adding up all of the people that answered. And that's why it's called cumulative. Cumulative means you add as you go. So in that line of the table, how many people have answered up above? So the cumulative frequency for the first line is just 1 person because there's only 1 person here. But in this line, what you answer is, you say how many people answered before you plus how many new people answered for a total of 5. So the cumulative frequency right here is 5. And then for this line, you say, well, 7 more people answered and 5, you add these two together. This is how many answered before. 7 more is going to give you an answer of 12. So 12 goes right here in this column. And then for this line, you say how many people answered before plus how many new answers. 12 plus 5 is 17, so 17 goes here. And then for this one, we just add these. How many people answered before and how many people are answering at this number. 17 plus 5 is 22. And then finally 22 plus 3 is 25. Notice that basically the very last entry in the table is telling you how many data points you have, how many people you have. Now this is the most important number. 25 is the most important number because it is telling you how many people answered your survey. That's important because you need to know, did 1,000 people answer or did 2 people answer? I mean, it's really important, right? So you need to know how many people answered. We just put a line item in the table. So we say at each little row, it tells you how many people answered above this, including this. So it's like 7 plus the 5 that answered before. Here is 5 plus the 12 that answered before. Here's the 5 plus the 17 that answered before. Here is the 3 plus the 22 answered before. So the very last entry is always going to be the cumulative, which is the total number of people who answered. So frequency means how many people answered a certain thermostat setting, and cumulative is just adding them all up down in the table. All right. Now the last thing we need to do is talk about something called a relative frequency. And this one's actually probably, in my opinion, the most important entry in the table. So it would be nice. I mean, this is useful. Okay, you can look at the frequency. You can say, oh, most people chose 70. Oh, there's some people that chose 71. Very few people chose 68. Okay, that's useful. But wouldn't it be more useful to express it as a percentage? A percentage is really, really useful. What if I told you that you took all the data in the neighborhood of all the people, the temperatures everybody wanted to set, and then I said 30% chose 70 degrees, 60% chose, or whatever, 60% chose, 72 degrees, and 40% chose a different temperature. Then you would know right away, because 60% of the people, that's a majority. You would know right away without having to dig through the data what most of the people actually indicated here. So what we want to somehow put in this column is a percentage. So it's a relative frequency, but I'm going to put a parentheses here. This is a percentage. We basically want to know what is the percentage of this answer compared to the whole thing. That's really what we want to know. So I'm going to back this table over here, and we're going to calculate these here. So for this first line, only one person said that they answered that they want 68 degrees, but there's 25 respondents. Remember, 25 respondents total. So 1 out of 25, that's the percentage of people that answered this entry, 68 degrees, 1 out of 25. So if you go over here and you say 1 out of 25, that is 1 divided by 25, right? And 1 divided by 25 actually works out to be 0.04. Just divide it long division or run it through a calculator. And if you put that as a percentage, you multiply by 100, move the decimal, that is 4%. 4%. And so what that does is you come over here and say the relative frequency as a percentage is 4%. And without filling out the rest of the table, you know immediately that 4% of the people that answered this survey in your neighborhood actually wanted this temperature. And we expect the numbers to go up from here because we had more respondents here. So let's take a look at this one. There were 4 people that wanted 69 degrees out of 25, 4 out of 25. So we can go here and say, what is 4 divided by 25, or 4 out of 25? And 4 out of 25 is 0.16. And if you convert to a percent, move the decimal 2 spots, 16%. And so we come over here and we say 16%. All right? How many people answered 70 degrees? 7 people, 7 out of 25. So you say 7 out of 25, 7 divided by 25 is 0.28. And as a percent, move the decimal, you get 28%. 28%. So 28%. Here we had 5 people answer out of a total of 25. So 5 out of 25. That's going to be 0.2 when you do that division. And when you multiply by 100, decimal moves 2 positions to 20%. So what do we put here? 20%. And then this is the same number of people answered as this. So this is 5 out of 25 also. So it's also 20%. And then finally, we had 3 respondents here, and 3 out of 25 works out to be 0.12, which is 12%. Just move the decimal 2 spots. So you get 12%. So we have 4%, 16, 28, 20, 20, and 12. Now this is our table. Now that we've built it ourselves and you know how it's constructed, let's go look at the pretty version of it, which looks a little overwhelming until you see how it's done. So these numbers, unless I've made a mistake, are exactly the same as these. I'm just going to take a look real quick. 1, 1, 4, 4, 5, 16, 7, 12, 28, 5, 17, 20, 5, 22, 20, 3, 25, 12, and then 68, 69, 70, 71, 72, 73. Here it is. Temperature, frequency, cumulative frequency, relative frequency. And I'm going to remind you that this relative frequency is a percentage, which you can see because of all the percent symbols there. I want you to notice that this is basically telling you, the reason it's called relative is because it's telling you compared to the whole, how popular was the answer? How many respondents did we get? We had 28% of the people choose 70 degrees, which is the majority answer, so it is the highest percentage. We had two separate entries for 20% each. 20% answered 71 degrees, 20% answered 72 degrees. A smaller amount answered 73, and the least amount, 4%, answered there. Now, what do you think is going to happen if you add up all of those relative percentages? They should add up to 100, right? So if you do that, 20 plus 20, that's 40. And then 16 plus 20 plus 4, that's another 20. So here you have 40, and then you have 60 here. And then you have, so 70, 88. You have 88 there. And then 90, and then 100. One more time, that's 40. And then this would be 50, 60. 70, 88, that's 88. And then 88 plus this is 90, and then 100. So the percentages add up to 100, which they should, because after everybody answers, the total percentage of everything that we collected should add up to 100%. So this is a frequency table. It tells you at a glance in a much more digestible way how to interpret the data. Instead of looking at this and you don't know anything about it, you're trying to figure out what was more common, who answered what. It's basically impossible. You can look at this and say, okay, well, the people that answered 69 degrees, 16% of them answered that, and here was the number of people that answered. It's just a way easier way to do it. So let's take a look at problem number 1. How many people prefer their thermostats to be set below 70? Below 70. If you look at the raw data, you'd have to go over here and you'd have to say below 70 is everybody here, and you'd have to count them. And that's kind of easy to do in this problem because there's only 25 answers. But what if I gave you 5,000 answers? Then you'd have to count them in the raw data. You're not going to do that. A frequency table is better. How many people prefer their thermostat set below 70? That doesn't mean 70, that means below 70. Everything below, then you just say 4 people wanted it at 69, 1 at 68. You add them together, the answer is 5. How many people below 70? 5. Now, when you say below 70, it does not mean 70. It means lower than 70. So we do not look at the 70 row, we look everything below that. Problem number 2, how many people prefer their thermostat to be set between 70 and 72? Between 70 and 72. So between 70 is right here, 72 is right here. How many prefer? You just add these numbers together. This is 10. 7 more is 17. So answer, 17 people prefer between 70 and 72 degrees. If you had to do this with raw data, you'd have to count them, but here in the table, it's just much, much easier to get the information. Problem number 3, what percentage of people prefer their thermostat to be set above 71, above 71. That doesn't mean 71 degrees, that means anything higher than 71 degrees. And you want the percentage higher than 71 degrees. Here is 71, we don't want that, we want everything above that. So we add these numbers up. 20 plus 12 more, 32. 32%. So what percentage wanted above this guy? 32% prefer to be above 71 degrees. What percentage of people prefer their thermostat to be set below 72? Not at 72, but below 72. Here is 72. You do not want this line. You want everything below that. We want to add up these percentages. You have 20, 30, 48. That's 48. And then these are 20, so 58, 68%. So you add these guys up, you get 68%. All right, so that is the first problem. We're going to take this down. We have one more, and then we're going to wrap up this lesson. All right, here is problem number 2. It says, Shane asked 10 students what their favorite colors were. So you have 10 answers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 answers. And of course, all of the answers that we have here. We have blue, red, yellow, red, red, blue, pink, blue, purple, pink. So we have lots of different answers here. Now, if I asked you, what percentage of people like red, just by looking at the data, you could calculate it, but you'd have to count everything. It's just hard, especially if the data is a large set of data, to look at the data and understand what it means. What is the most common color? What is the least common color? Yes, you can get it from looking at it, but it's difficult. So let's make a frequency table. Now we could draw it and calculate it like we did, but I think now that you know how it's laid out, we can go straight to the finished product. We have the color. This just means the answers that we got. We have blue answers, pink answers, purple, red, yellow answers. Now we have to create the frequency here. How many people answered blue? Well, we have 1, 2, 3 people answered blue. How many people answered pink? We only have 1 here and 1 here. That's 2. How many people answered purple? Only 1 person answered purple. How many people answered red? 1, 2, 3 people answered red. How many people answered yellow? and only one person answered yellow. So again, it's difficult to look at this and understand, but when you look at this, it's very easy for you to see, okay, the people who picked purple and yellow were the least most common, the lowest frequency, where it seems like people like red and blue the most, followed in second place, or I guess in third place, however you rank it, by pink. So it's easier to digest it from the table. Now, the cumulative frequency, the very last line item, should always be the number of respondents. Notice that we asked 10 people. We have 10 answers here. So if we add these up, 3 plus 2 is 5, then 6, then 7, 8, 9, then 10. There's 10. The way we construct this is the first line in the cumulative frequency is just this number. And then, however many we get for the next one, we add them together and get 5. So 5 is the new respondents here plus how many answered before. Then for this line, it's the new respondents plus how many answered before to 6. Here, it's the new respondents plus however many answered before. 6 plus 3 is 9. And for here, it's how many new respondents plus however many answered before, which is 10. So the bottom number should always be the total amount of answers you have. The sum of this column, in other words. All right, next, we calculate the relative frequency. And these numbers work out to be really, really nice, because if you look at it, what's the relative frequency in this one? It is 3 people answered out of a total of how many? There's 10. The cumulative frequency at the end is just 10 people, 3 out of 10. Now, when you divide by 10, you just move the decimal 1 spot to the left, 0.3. And then as a percentage multiplied by 100, it's 30%. And so we have 30% here. For this one, it's 2 out of 10. It's the same sort of thing, 2 out of 10, 0.2, which means 20%, because we move the decimal 2 spots here. For this line, it's 1 out of 10, which works out to 10%. For this one, it's 3 out of 10, again, 30%. For this one, it's 1 out of 10, again, 10%. And as before, if we add up all the percentages, this becomes 50, then 60, then 70, 80, 90, then 100%. The relative frequency should add up to 100%. Now, this is nice because you can look right away and say, okay, the least popular colors at 10% a pop is purple and yellow. The most popular colors at 30% each were red and blue. And that is a much better way to present this data in a frequency table with a relative frequency in a percentage, because then you can just easily digest what the data is telling you. All right. Now let's take a look at our first actual problem. How many students chose either pink or purple? Pink or purple? So we look in the pink, we look in the purple. How many students? How many respondents? Together, 2 plus 1 is 3. So only 3 people chose pink or purple. You can get this answer by going to the raw data and counting, but from the table, it's much faster, especially if the data is very long. How many students did not choose red? So here's red. So how many people did not choose red? Well, that will be 3 plus 2 is 5, then 6, then 7. We skip over that for 7. How many people didn't choose red? 7. Next problem, what percentage of students chose a primary color, which is red, blue, or yellow? What percentage of students chose a primary color, red, blue, or yellow? Red, I'll put a little dot here, blue, red, or yellow. So these 3 here. So it's 30, plus 30 is 60, plus 10 more is 70. 70% chose a primary color. Just add the percentages. 70%. Last question. The school's colors are blue and yellow. What percentage of students chose one of the school's colors, either blue or yellow? Right? So here is blue. Here is yellow. 30 plus 10 is 40. So 40% chose either one of those. 40%. So this lesson hinged on kind of 2 things. Number 1, we have to explain how to take raw data and put it into a frequency table. So for the first problem, we did it all from scratch, and it showed you exactly how it comes about. It's just a matter of counting up the responses. That's what's called a frequency table, when you tally up or count the responses and put the number of responses in a table. Instead of listing every result, you just tally up the total number of each little category. And then we had the relative frequency, which is just figuring out how many respondents we had divided by the total number and converting that to a percentage. Now you know why, one additional reason why percentages are so important. And then the cumulative frequency column is mostly used basically because we have to add them all up anyway, and we just make a line item in the table to be able to add them all up. Okay, so we learn how to make that table, and then we most importantly learn how to use that table to answer questions. None of it's rocket science, right? Like when you jump into it, you can see that these answers are simple, but if I don't explain how to get the table, if I jump into this table and say, hey, here's a table, then it looks overwhelming. So for that first problem, we do it ourselves. And then now you know how the tables are put together and you can get practice with it. So I'd like you to go through these, make sure you understand where everything is coming from. Follow me to the next lesson. We're going to continue working with frequency tables in probability and statistics.